Okay, here we go. To finish up Unit 9, polar equations, polar functions, we are going to actually focus on graphing. I do have 3 Desmos investigations up there that you can use to mess around with the graphing before you actually go through this, just to kind of see what you're getting yourself into. So those links are there, obviously not required, just for you to kind of to get your feet wet and see what's going on. So this is a topic that you will need for BC Calculus. We will use this. Again, I'm not giving you any tests or quizzes. It's just so that you can kind of get used to it, see it, be ready for next year. Okay, so we're graphing polar equations or polar functions. So we talked about polar coordinate system. So a polar equation is an equation whose variables are and theta. The graph is the set of all points whose polar coordinates satisfy the equation, and the polar grid is used to graph polar equations. So we have the pole and our polar axis. And we're going to get right to this. We're going to go ahead and graph the polar equation using this table. And we're going to go ahead and plug some values in to find our polar coordinates that we need to plot on the graph. So we are going to do 4, not sure why that changed, times cosine is 0. Add 0, cosine is 1, so we have 4 times 1, which is 4. So we have the ordered pair, sorry, the polar coordinates 4 at an angle of 0. So at an angle of 0, we're going to go 1, 2, 3, 4. Okay, next we are going to plug in pi over 6. And at pi over 6, we get the square root of 3 over 2 for cosine. So when we simplify that, we get 2 square root of 3, comma, pi over 6. So at the angle pi over 6, we're going to plot about 3.5. So this is pi over 12. So pi over 6 is 1, 2, 3, about 0.5. Now we're going to do the next one. 4 cosine of pi over 3 equals 4 times 1/2, which gives us 2. So we have 2 pi over 3. So at pi over 3, we're going to go up to 2. 1, 2. At pi over 2, our x value is 0. So we have 4 times 0, which is 0. So we have 0 pi over 2. So that puts my point right back here. At 2 pi over 3, we have a cosine value of negative 1/2. Remember, cosine is negative in the second quadrant. So 4 times negative 1/2 actually gives us negative 2. So we have a radius of negative 2, comma 2 pi over 3. So here's our 2 pi over 3. If it's negative 2, I have to go the opposite direction. So I'm going to go 1, 2. 5 pi over 6, we get 4 cosine of 5 pi over 6. And to simplify that, we get negative square root of 3 over 2. So we have negative 2 square root of 3, comma 5 pi over 6. So again, we're going to go to 5 pi over 6, which is right here. And then we're going to go negative 3.5. 1, 2, 3.5. And then when I plug in pi, I get 4 times cosine of pi, which is negative 1, equals negative 4. So negative 4 comma pi. So at this angle, I'm going to go back 4, 1, 2, 3, 4, and end up where I started. And I actually end up with a circle here. So that goes back to our whole changing equations to rectangular form. That's why we end up with circles. So what you will notice at the bottom of your page is the graphs of r equals a cosine of theta and r equals a cosine, that should be sine of theta, are circles. It's 2 typos. Next page. Before we graph anything else, we're going to test for symmetry and make sure they work out all right. So we're going to go ahead and check to see if it's symmetric with respect to the polar axis, which is typically like your coordinate or your x axis. And we're going to replace theta with negative theta and see if we get the same thing that we started with. To decide if it's symmetric with respect to the y-axis or pi over 2, we're going to replace r with negative r and theta with negative theta and see if the result is true. And then if we're going to decide if it's with respect to the origin, we're going to change our r to negative r and see if that ends up being true. One thing you do need to know is when you test for symmetry, it might fail the test, but it might still be symmetric. So keep that in mind. I'm actually going to do one more problem in this video, and then I'm going to show you some calculator stuff, and then I'm going to go do the next video for the last two examples. So when we're doing this, we're going to test for symmetry. So the first test for symmetry is to plug in negative theta and see if I get the same thing. So when I plug in negative theta, meaning if I go to this angle or I go to this angle, is my value the same? Well, since all students take calculus, cosine is going to be the same in those two. So if I go positive theta versus negative theta, this ends up being 1 minus cosine of theta. So we do know that that one works. If I change r to negative r and I change theta to negative theta, I end up getting this. And then because of the negative r there, this is different than what I started with, so that's not symmetric there. And then if I do just negative r, okay, if I change this, I end up getting r equals cosine of theta minus 1, which is what this ends up being as well. So those two aren't the same, so that means it's only symmetric about the x-axis. So when I'm plugging in points, I really just need to plug in points that are above the x-axis, and then flip them over. So I am going to plug in a bunch of angles to find my radius. I'm going to plug in 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, keep going, 5 pi over 6, and pi. You don't have to do all of these. Like you could leave pi over 4 and 3 pi over 4 out if it saves you time. It's up to you. But cosine at 0 is 1, so 1 minus 1 is 0. Cosine at pi over 6 is square root of 3 over 2. So if you do 1 minus the square root of 3 over 2 in your calculator, you get 0.13. Pi over 4 is the square root of 2 over 2, so if I plug in 1 minus the square root of 2 over 2, I get 0.29. At pi over 3, cosine is 1/2, so 1 minus 1/2 is 1/2. At pi over 2, cosine is 0, so 1 minus 0 is 1. At 2 pi over 3, we get a negative 1/2, so 1 minus negative 1/2 is a positive 1.5. At 3 pi over 4, we get 1 minus negative square root of 2 over 2, which is 1.71. At 5 pi over 6, we get 1 minus negative square root of 3 over 2, which is 1.87, and then 1. Okay, so I'm going to go ahead and plot those. At 0, 0, pi over 6 is 0.13, so this is really small here. Pi over 4 is 0.29. Pi over 3 is 0.5. Pi over 2 is 1. 2 pi over 3 is 1.5. 3 pi over 4 is 1.71. Whoops, I marked those in the wrong spot. Let's undo those last two. Move them over one. 1.87 at 5 pi over 6, and then I get 1 for pi. So you will notice that we have this little shape here that looks kind of like a heart when you reflect it. So I'm just going to reflect this point, reflect this point, reflect this point, reflect this point, and then we're going to get smaller there. So it goes like this. Okay. Now, when you are finding your values for these points, and if you're using your calculator and plugging it in, like 1 minus cosine of pi over 6, which is fine, I'd like you to practice memorizing those, but you do need to be able to recognize if your calculator is in the right mode. So make sure it is in radian mode, not degree mode. Otherwise you get a really weird answer. Change it to radian mode and you should be good. Okay, before I let you go, I want to show you two things. A lot of you have graphing calculators. We can graph this using a graphing calculator. So I have 1 minus cosine of theta. Before you do that, change your modes. So hit your mode key. We need to go down. Oops, sorry, I went down too far. To where it says function and go over and hit polar, enter. Again, make sure it's in radian mode. So when I go to type this in, you'll notice it changed it to R. So I can type in 1 minus cosine of theta. And then I'm gonna go ahead and graph that. So you'll see we have what we call here is a cardioid. Okay, it looks like a heart. So I'm gonna go ahead and hit pause after this. One more graphing calculator in Desmos. Same thing. To change this, you're gonna hit the little wrench here. You're gonna change it to polar and keep it in radians. And we're gonna do 1 equals 1 minus cosine. For this, you can type in theta and it'll enter it for you. Again, we have a cardioid there. So just wanted you to be familiar with all your graphing features just so you can check your work as you go. I do like you to do this by hand because it's good to remember those values. Okay, so this is video 1. I'm gonna come back and do 2 more graphs so you can see those, and then that'll be it for polar functions.